Today we're going to talk about the concept of tangent lines in calculus. The first question says, find the slope of the graph of the function at the given point. You may sometimes see this also written as find the slope of the tangent line to the graph of the function at the given point. So if you remember with our work with derivatives, the derivative will help us find the slope at any given point. So the first step when approached with this problem is to find the derivative of the given function. So in order to find the derivative, step 1, find derivative, which is written f prime of x. It does help if you can rewrite your function as 3 times x to some power, so it's not as a quotient. So let me do that over here. So to just rewrite that as 3x to the negative second power, it's equivalent to 3 over x to the positive second power. The reason it's important to do this is now we can apply the power rule for finding derivatives. So the derivative f prime of x equals, if you remember the power rule, it says take your power, the exponent, -2, you multiply it by the coefficient of x to get -6, and you subtract 1 from your exponent. So that makes it -6x to the -3rd power. And now what I'm going to have to do is evaluate this derivative at a particular point. They tell me the point is 1, 3. So if I know I'm going to be substituting a number for x, I'm going to probably change this function here, this derivative, back to a form I'm a little more familiar with. So I'm going to move that x to the -3rd to its equivalent form would be -6 over x to the 3rd. And now what I want to do is evaluate the derivative at the given value of x. Now they give me the point 1, 3. I'm just concerned with what is the x value. So of course every point gives us an x and a y. So in this case I want to know what is the value of the derivative at x equals 1. So I'll come over here, find my derivative, and evaluate f prime of 1. So that's substituting a 1 for x. 1 to the 3rd power is 1. -6 divided by 1 is -6. So I have just found the slope of the graph at the point 1, 3 is -6. And next what I'll do is I like to test that or show that graphically. So let me go grab your graphing calculator if you have one. And what we're going to do is type in, hit your y equals button, and we want to type in that function we were given, which was 3 over x squared. So 3 divided by x squared. If you go ahead and hit graph right now, you can see what this graph looks like. This is a rational function. It has those two pieces. However, we're only concerned with the piece wherever 1, 3 would be. So we really are just concerned with the piece that might show up in the first quadrant. So what I'm going to do is change the viewing window so I can just show maybe that first quadrant. So I'm going to go to window, and I just want maybe to change my x min to 0 and my x max to 5. Same thing for y min and y max, 0 to 5. Hit graph again. And we can see just the first quadrant. And what we were concerned with was what is the slope of the tangent line to this graph at the point 1, 3. So 1, 3 clearly would be in this first quadrant, right here. So what I want to do is to check this with my calculator. I can hit second, trace, and it brings up the calculate menu, and if you look at option number 6, it says dy dx, the derivative of y with respect to x. So if you hit number 6, it will give you a pop-up little cursor down here, and it will let you choose your x value. And if you remember, our x value was 1. We wanted to know what the slope was at 1, 3. So hit 1 and then enter. And there, the cursor pops up right there at 1, 3, and it tells us the derivative is -6. Just what we determined. Okay, next. We're going to take this one step further, and we are going to go determine the equation of the tangent line to the graph of the function. So in my next problem, I want to know what is the equation of a tangent line to the graph of my function at the given point. So notice I have changed function so you can see a little bit different equation. Now we're going to look at the function y equals x squared at the point -2, 4. So we're actually going to start out the same way that we did on problem number 1. Before I can find an equation of a line, I need to know what the slope of that line is. So in order to find slope, that requires me to do a derivative. So step 1, again, would be find the derivative of my function. So find f prime of x. Using power rule, the exponent 2 gets multiplied by this coefficient of 1, making that 2. The exponent gets subtracted by 1, making it 2x to the first. So the derivative of f is 2x. F prime of x is 2x. Now, luckily they do give us a point, so -2, 4 is an x, y. We want to evaluate our derivative at that x value. We want to know what is the value of the derivative when x is -2. So I'm going to substitute -2 for x, and I get a value of -4. So f prime of -2 is -4. What I just found there is the slope of my tangent line. So if you remember from algebra, typically we use the letter m to represent slope. And if we're going to write an equation of a tangent line, an equation of a tangent line, I'm going to use the slope-intercept form of an equation of a line, which is y equals mx plus b. Now, luckily, I do have an m, I do have a slope, and I do have a point, so I also have an x and a y. So I have 3 numbers I can substitute into this equation to find my b, or my y-intercept. So I'm going to go ahead and substitute 4 for y, -4 for m, x is -2, plus b. And multiplying here gives me 8. Solving for b, I would subtract 8 on both sides and get a value of -4. So the equation of my tangent line, if I want it in slope-intercept form, I already know my slope is -4. I found that earlier. And I just found my y-intercept, which happens to also be -4. So I will put those two together in slope-intercept form as y equals -4x minus 4. So that is the equation of the line tangent to the graph of y equals x squared at the point -2, 4. And just like before, we can check